Okay, this is lesson 5.2 part 2, and we're going to keep working on proofs. So let's start with number 1. I'm going to start on the left side. I see that I have a square on top, cosecant squared, and that is equal to 1 plus cotangent squared. Now, next thing I can do is I can split this up into two parts. I can write this as 1 over cotangent plus cotangent squared over cotangent. 1 over cotangent is equal to tangent, and then this simplifies to just cotangent. Now I can use my trick for converting everything to sine and cosine. Tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. Okay, last thing I'm going to do is combine this into one term. So my common denominator would be cosine times sine, which means I'm going to have to multiply this first fraction by a sine and the second fraction by a cosine. So this gives me sine squared plus cosine squared over cosine times sine. Now, sine squared plus cosine squared, that's a Pythagorean identity. That's 1. 1 over cosine is secant. 1 over sine is cosecant. So I'm just going to reverse them because my answer is reversed. So that would be cosecant times secant, which is equal to cosecant times secant. Okay, the second proof, number 2, we have tangent squared plus 6 equals secant squared plus 5. Now this one's a pretty easy one. I could do either side. They're both pretty similar, but I see a squared, so I'm going to go down to the Pythagorean identities section, and I see that secant squared is equal to 1 plus tangent squared. And I'm going to bring down the plus 5. Now, if I add the 5 and the 1, I get 6, so tangent squared plus 6, and that equals the left side, tangent squared plus 6. Okay, moving down to number 3. Now number 3, this first part here looks a little different. That comes from our cofunction identity. So if you look at your formula sheet, the cofunction identities are right here. Those are the ones that add up to 90, so they give you the same value. Well, right here I see the same thing. Cotangent of pi over 2 minus x, that would equal tangent. So I'm going to replace that cotangent with a tangent. And I'm going to use the trick to change everything to sine and cosine. Tangent is sine over cosine. Cosecant is 1 over sine. Now when I cross multiply, the signs would, or not cross multiply, when I multiply the two fractions, the signs cancel out and I'm left with 1 over cosine, which is equal to secant. Okay, moving over to number 4. So I'm not going to do the left side, even though that looks crazy. I'm going to start with the right side because I have tangents instead of sines and cosines. I want to try to work with the part that I can convert to something else. And I can easily work with tangent because what I can do is convert all those tangents to sines and cosines. Now you do have to be careful because some of these are x's and some of these are y's. So this tangent of x would be sine of x over cosine of x, plus this one would be sine of y over cosine of y, all over 1 minus sine of x over cosine of x, sine of y over cosine of y. Now I'm going to get a common denominator so I can combine all of these things together. So if I look at all the denominators, I've got cosine of x and a cosine of y. So I'm going to multiply every term, and there's 4 of them, by cosine of x, cosine of y. Okay, and let's cancel and then multiply what's left. So cosine of x is cancel. So that would leave me with sine of x, cosine of y, plus the cosines of y's cancel. That would leave me with cosine of x, sine of y, over 1 times cosine of x, cosine of y, minus all the denominator cancels, so we're left with sine of x, sine of y, and that perfectly matches the left side. Okay, let's go to number 5. And I'm definitely going to start with the left side. The left side has a lot of stuff going on. So I'm going to convert some of the secants into maybe some sines and cosines, or I can try to factor. There's lots of things I could do here. So I kind of see a sine squared and a cosine squared. Sine squared plus cosine squared is +1, but this is negative sine squared minus cosine squared. So since it's the opposite, that would equal -1. Okay, the first two terms, I can actually factor something else out. They both have a 2 secant squared. And I would be left with 1 minus sine squared. Now immediately I recognize this 1 minus sine squared. That is cosine squared. Okay, so secant I know is 1 over cosine squared. These cosines would cancel. And I'm left with 2 minus 1, which is 1. And I forgot that I had a typo on this question, and that this should not be a 0. This should actually be a 1. So I forgot to say that at the beginning. I should have, but I forgot. So otherwise it wouldn't have worked out. So the answer is 1, which equals 1. Okay, number 6. So I'm going to remember to say this at the beginning. Number 6 also has a typo. This is really cosecant squared. I'll change these on your notes though. But on my paper, it's going to have a typo. So you guys should be seeing cosecant to the 4th x minus 2 cosecant squared x plus 1. Now, I can factor this. This is like having x to the 4th minus 2x plus 1. I would set up 2 parentheses. I would put a cosecant squared in front of both of these. Factors of 1 that add up to 2 would be 1 and 1. They're both going to be negative. And from my Pythagorean identities, cosecant squared minus 1 is equal to cotangent squared. So I've got 2 of those. If I combine them, that means I have 4 of those. Okay, last question, and we did one similar to this in part 1. So we have 2 sides, and both of them look pretty similar. I could start with either side. I'm going to start with the left side, and I'm going to, just like we did in part 1, I'm going to multiply top and bottom by the reciprocal, which is 1 plus cosine beta. So on top, I'm left with sine of beta times 1 plus cosine of beta over, now the bottom I'm going to FOIL, but I only have to do first and last. That would be 1 minus cosine squared beta. Now that is a Pythagorean identity. 1 minus cosine squared is sine squared. So I'm going to rewrite this. Sine of beta times 1 plus cosine of beta over sine squared. And now I have a sine on top that can cancel with one of the sines on the bottom. So I'm left with 1 plus cosine of beta over sine of beta, which is equal to the right side. So again, the important thing to remember on a proof is to show every step. You want to only stay on one side. Try all of the things that we have been writing down as tricks to try when you prove one side equals the other side. And again, the more you practice these, the better you will get. Go back and rewatch the questions that you had a hard time with. You can rewatch them as many times as you want. And again, the only way you're going to get better at these is if you practice them.